All right, guys. Just trying something new today. I want to just go over some stuff that a lot of you guys have been questioning, that have questions on in the last 2 weeks of this quarantine season, I guess. Right. So the first thing I want to talk about right now is the three conditions for correlations. The three conditions for correlations. Okay. A lot of people are writing the three conditions are the direction, the direction, the form, and the strength. These three things are not. These three things are not your conditions. These three things are your description of a correlation. Okay? They're your description. You describe a correlation using those three things. Before you can even do that, though, you have to follow the conditions. The three conditions are is it linear? Or can you make it linear? The second one is no outliers. Remember, outliers kind of throw off our data. And then finally, the third thing, probably the most important thing, is quantitative data. Quantitative. God, I hope I spelled that right. Variable. What I mean by that is you have to measure two things that are quantitative. You cannot measure, for example, eye color versus shoe size. I don't know. Shoe size is quantitative. That's fine. But eye color is categorical. You can't assign a number to that, right? It's not measured by a number. So this will fail the condition. Therefore, you cannot create a correlation from there. All right? The next thing I want to talk about is this thing called a lurking variable. This is probably one of the harder things in this chapter to kind of understand. And what a lurking variable is, it's a variable that is hidden. And what I mean by hidden is that it's not specifically said, like given. That is hidden, that is responsible for a correlation. Okay. That's kind of as simple as I can put it. An example that we did in the notes was the number of firemen and the money in damages. If you guys remember correctly, the example was a positive correlation. And what that's saying is that, as number of firemen, I'm going to write FM, increases, money in damages increase. Now, yes, that is technically true. But is that to say that you should not have more firemen at your house if your house is on fire? No, right? Sure, firemen do create damage to your house in that sense. But here, the point that I'm trying to make is that there's a lurking variable here. And lurking variable in this problem would probably be the size of the fire. The bigger the fire, the bigger the fire, you're gonna need more firemen. The bigger the fire, the more money and damages there are. So that's kind of the variable that's kind of in between the two that ties them together. And that's what a lurking variable is. It's really hard, and you guys are going to need to do examples to kind of see it more, right? And if you need more, just give me a text on that Google Voice number, or just email me, or leave me a classroom comment, and I'll look up more, and I can just give you guys more examples of a lurking variable. Okay. All right. The next thing I want to talk about: correlation versus causality. Correlation is talking about patterns and trends. Causality is focusing on cause and effect. Just because there is a pattern or trend, just because there's a correlation, does not necessarily mean that there's a causality. If we look at this last example of the damages in fire and the number of firemen, there is a correlation between the two, right? As number of firemen increase, the number in damages also increase. That's a correlation. But does number of firemen directly relate? Does the firemen directly influence the dollar in damages? I would say no, not really. It does play a role. What plays a role more is the size of the fire. Okay, you guys have to separate. Does one thing lead to another? Okay, if you're playing the stock market and you see that stock prices are rising, or whatever, that's just a pattern or trend. That's just a trend, right? Or a pattern. You can't say that, oh, with more time, as time increases, the stock will for sure increase. We don't know that. We can only say that that's a pattern or a trend that we see from beginning to wherever the graph ends. But it's not correct to say that time is direct cause of the money, if that makes sense. Okay. Now, that's not to say that that's not always true. There are stuff that will probably tie hand in hand with one another. Something that I can kind of see is if we're doing I don't know, we do shoe size versus height of a person, or vice versa. You can make a claim that these two things have a cause and effect relationship for the most part, that the taller you are, the bigger the shoe size, just because like you're getting bigger and you need bigger like the shoes need to be bigger to balance you out. Like that can be a thing. There's a correlation and there's a cause and effect, or a causal, I don't know if that's a thing, but there's a causality between the two. Okay. I'm going to move on to finally the last thing that I want to talk about is linear regression and line of best fit. These are just two different definitions. They mean the same thing. Okay. They mean the same thing. They mean to find the best line. Y equals, really just determines what they do. B plus AX or something along that line. So it just means that. You can also have Y equals AX plus B. They should mean the same thing. Okay. So linear regression and line of best fit mean the same thing. But in order to do that, remember, we have to satisfy our three conditions. Okay. Yeah, I think that's about all I have. Like I said, you guys should know how to contact me and be able to contact me if you guys need any help. I think I might create a Zoom kind of office hour for next week, maybe 1 day or 2 days a week, depending on depending on availability and stuff. But yeah, yeah, that was fun. Okay, bye.